Hi guys, this is Che. I'm doing homework 5, question number 1. So the question is asks us to prove that C is equal to x plus y. So we know that the big F of C is equal to the probability of the z variable, which is less than or equal to z, and this is equal to the probability of the big X plus big Y is also less than or equal to z. And we know that this is just the big F of x plus y. And now we can write this as the double integral of small f of xy dx dy. So we have to consider this question in two cases. So y is less than or equal to z minus x. So if we have x plus y smaller than or equal to z, then we have z is smaller than or equal to y is smaller than or equal to z minus x, and so we have minus x plus z. We have this graph here. So this graph is z minus x, and the everything below this line here is y. And now we think of x is smaller than or equal to z minus y, and we have the same graph, but if we put x here and then y here, so negative y plus z, and this line is z minus y, and the area below this line is x. Okay, so now we have f of z is equal to the double integral of f xy dx dy. I'm sorry, dy dx. For this is when y is smaller than or equal to z minus x. And now we have okay, so because we take the y integral first, and this range is for the y range, and y is from negative infinity to this line, so it will be from negative infinity to z minus x, and for x it's just negative infinity to infinity. Right, and now we do the little f of z, which is equal to d dz f z. This is equal to the integral of d dz the integral from negative infinity to z minus x f xy dy dx. And we can write this as the integral, oh sorry, here is from negative infinity to infinity. And now we have this integral of f x c minus x dx, right? So this is for when y is smaller than or equal to z minus x. What if we do the same way for x is less than or equal to z minus y? We have f of z is equal to the integral from negative infinity to infinity f x z minus y dy. I'm sorry, here's y. Wait, no, I'm sorry. It will be d x dy, and x will be from negative infinity to z minus y right. So f of z will be the integral from negative infinity to infinity f z minus y dy. And this is for x is less than or equal to z minus y. And if x and y are independent, then from this we get f xy is equal to fx z x times fy y. And we have f z equals to the integral from negative infinity to infinity fx x times fy c minus x in this case dx. And this is just f of x, I don't know, this is f y of z convolved with f x of z. And for this one here, we have we will have the same thing. But we will have f c time equals f of z equals f x of z to come up with f y of z, which is the same thing. And we can, the second method for doing this problem is to use the unit step function. And one second.